Hello everyone, and I welcome you all in this learning video. In the last learning video we have seen what is Lagrange's equation, that is the partial differential equation of first order and first degree, followed by the solution or the working rule to get the solution of Lagrange's equation, and then we have seen the three different methods which can be helpful in getting the solution of Lagrange's equation. Okay, so the scenario of this lecture and the next lectures will be like I will be taking one method, then a problem on that method, then the second method, and then the problem of that, then the third method, and then 2-3 example on third method, and at last we are going to make it more interesting by taking example. At any random example we will be taking, and we'll try to we'll try to test our knowledge whether we can solve and whether we can apply our buddhi to get the solution of that given differential equation. Okay, so without much ado, let us start with this problem. So as I said, in this learning dialogue I will be taking a problem on method 1. Okay, so this problem says solve xzp plus yzq is equal to xy. Okay, so do you remember what was the working rule? The very first step says write down the given equation in the form PP plus QQ is equal to R. And as you can see, the problem is itself is in the form. Okay, so you can write like the given equation is xzp plus yzq is equal to xy. Okay, and if it is in the form, well and good. If it is not in the form, try to rearrange. But as this is of the form, so you can write this is of the form pp plus qq is equal to r. Okay, so where what is P? Can you tell me what is P? P is xz. What is capital Q? Yz. And what is R? Xy. Okay, this completes my step number 1. Okay, if you want you can give this to the equation 1. Then what is our step number 2? Our step 2 is to write down the auxiliary equation. So you can write its auxiliary equation is what is its auxiliary equation? Do you remember? So I want you to just pause the video for a few seconds, try to recollect the auxiliary equation for this Lagrange's equation, okay, and resume the video. So I hope you might have written the auxiliary equation. So I will write first the auxiliary equation dx by p, dy by q, and dz by r. That is one can write like dx by xz, that is my p, dy by q, yz, and dz by r. What is r? xy. Simple. Now, see, this is to be equation number 2. Now, we are going to apply the method of grouping. And what method of grouping says? Take any two ratios. So, I will be taking first and second. So, method number 1 says take any two ratios. If anything get cancel it and integrate to get the first integral solution. Simple. So, I will be taking dx upon xz is equal to dy upon yz. That is the first ratio I have taken. Now, anything will get cancelled? Yes, this z will get cancelled with this z get cancelled with this z. Okay, and we remain with what? We remain with dx upon x, dy upon y. That is dx upon x. I will take it to the left and write dy upon y is equal to 0. Now this is very elementary integration. Just integrate to get the solution. On integrating, we get what we get. Integration of 1 by x is log x. Integration of 1 by y, log y, log a. Constant of integration. Okay. Now, whenever you are taking two ratios, one remark I would like to make. Whenever you are taking two ratios, okay, so you have taken dx and dy. So try to eliminate z so that this will contain only x and y, so that I can easily integrate it and easily I will separate the variable. Okay, so we have this, and if you want, you can solve this further. You can solve this further to get what is this, log x minus log y. So that is the formula. Log a minus log b is log of a by b. Okay, so this is like log of a by b is log of x by y is equal to log a. Okay, and then you can do one more thing here. So one more thing that you can do here is remove the log by taking exponentiation. This implies x by y is equal to a. That is my first integral curve. Okay. Now let us try to solve this. I have taken first and second, so I cannot take first and second again. I can either take first and last, okay, or I can take first and last. So first and last, x get cancelled, then z and y will be there. So no, I am not going to take first and third. So rather I will go with this second and third. So what is second? dy by yz, and this is dz by xy. Okay. Now as you can see, this y. So why it cancel? Let me check. What is the problem? Dx is xz and dz is xy. Okay, this dx is xz, dy is yz, and dz is xy. Okay, okay, no problem. Okay, so we have taken this. Now anything get cancelled, so y get cancelled with this. Okay, now what we have dy by z and dz by x. Okay, but we have dy and dz. So all I want is the term of y and z only. So who's creating the problem? This x is creating the problem. So I will put the value of x as ay. Okay, so this is like dy by dz is equal to dz upon what is x? X is ay. Okay, now you can separate the variables. So it is like ay dy minus z dz is equal to 0. Integrate. On integrate you will be getting a y square by 2 minus z square by 2 is equal to b. Okay, now replace the value of a is x by y. So I am writing here. So what is it? A is x by y. So this is x by y into, I can write b by 2 just to get this 2 cancel. X by y into y square by 2 minus z square by 2 is equal to b by 2. So this get cancelled with this. So we remain with 2 get cancelled throughout. So we have xy minus z square is equal to b. So this is the second integral solution that I have got. Now don't forget to write down the general solution after you get this solution. Okay, so let me write. Therefore the general solution is, what is it? Phi of AB is equal to 0. That is phi of what is A? What is A? A is x by y. And what is B? B is xy minus z square is equal to 0. Where what is this phi? Where phi is an arbitrary function. Okay, so this completes the solution of the problem. Okay, so we have one problem. Now let us take one more problem to make it more clear. And just because this is the first problem, we have written very systematically each and every steps I have covered in this. Now let us take another example and solve it. So let us take example number 2. So example number 2 says solve. What is the problem? P 10x plus Q 10y is equal to 10z. So this is the problem we have, and we have to get the solution of this. Okay, so what is the first step? The first step is to write down the given equation of the form PP plus QQ is equal to R. Okay, we can write the given equation is 10x into P plus 10y into Q is equal to 10z. Okay, so this is of the form PP plus QQ is equal to R. Here what is capital P? Capital P is 10x. What is capital Q? That's 10y. And what is capital R? That's 10z. Okay, so we have P, Q and R. Let us write down its auxiliary equation. We can write its auxiliary equation is what is it? Dx by P, dy by Q and dz by R. Okay, now just write down its auxiliary equation, putting the value of P, Q, R. So just substituting the values of P, Q, R, you will be getting like that is dx by 10x, dy by 10y and dz by 10z. Okay, so we have this. Now solve. What is method 1 says? Make a group. So this is a very simple example. These are already in groups, so you just write consider. So I will take first 2. So it is like dx upon 10x and dy upon 10y. Okay, now this is already variable separable, so you can write it as like that is 1 upon 10x is cot x dx minus, take it to the left, this is cot phi dy equal to 0. Now just integrate. So when you integrate, what you will be getting? On integrating, we get integration of cot log of mod of sin x minus log of mod of sin y is equal to log a. Okay, now you can apply the properties of logarithm. So what is log a minus log b? That is log of a by b. So I'll be writing log of sin x upon sin y. Log of sin x upon sin y is equal to logarithm a. Okay, now this log get cancelled from the both side by taking exponentiation. So you'll be getting, what will be getting? You'll be getting sin x upon sin y is equal to a. Okay, so that is the first integral curve or first integral solution or first integral surface. Okay, this is the first solution. Now I want you to pause the video for a few seconds and try to solve. We have already taken these first and second. So what are the other possibilities we have? Second, third, or first, third, whatever you can take. Yes, let me tell you one thing. Suppose some student takes second and third, so they will be getting some other answer. Okay, if I am taking first and third, I will be getting other answer. But here for the given problem you can have more answers. Okay, like if I have taken second and third, my answer would be different. If you have taken first and third, your answer may be different. So it depends. Okay, so here does not necessary that you will all be getting the same solution. Okay, but you must get because of this selection of ratios. Now let us take the, which should I take? Let us take first and third. Dx upon 10x is equal to, dz upon 10z. So we have this, then separate. So this is cot x dx minus cot z dz is equal to 0. On integrating, we will be getting log of sin x minus log of sin z is equal to log of b. Apply log a minus log b to get log of sin x upon sin z is equal to log b. That is, log get cancelled from both the sides. Sin x upon sin z is equal to b. So we have the second solution. Now at last, you are smart enough to write down the final answer. So what is the final answer? Can anyone tell me what is the final answer? The final answer is the general solution. The general solution is, what is it? Phi of AB is equal to 0. That is, phi of what is a? Sin x upon sin y, and then sin x upon sin z is equal to 0, where phi is an arbitrary constant. Okay, so this completes the solution of this problem. Now likewise we can solve the problems by using method 1 to get the solution of Lagrange's equation. So thank you for watching this learning video. Good day.